Hello, welcome back to my channel. In this video, I'm going to be explaining hybridization. Hybridization is a concept used in chemistry to explain the shape and bonding of molecules by fusing or mixing atomic orbitals to form new hybrid orbitals. So these hybrid orbitals have shapes and orientations that help explain molecular geometry based on VSEPR theory. Now, VSEPR means valence shell electron pair repulsion. Okay. The first type of hybridization we have is sp hybridization. The orbitals mixed here is one x orbital plus one p orbital. So that ends up giving us sp hybridization. The geometry, so geometry is simply known as shape, okay? The shape of molecules that have sp hybridization will usually be linear. And the bond angle for linear molecules is 180 degrees. A typical example of this would be carbon dioxide, CO2. So if we are to draw out the structure, CO2 is C double bond O double bond O. Okay, this is the complete Lewis structure. So that is linear. Linear just simply means a straight line. And that's a typical example of a linear molecule. The second type of hybridization is the sp2 hybridization. This is a mixture of one s orbital and two p orbitals, which leads to sp2. The molecules that usually have sp2 hybridization will have a geometry known as trigonal planar. Trigonal planar. The bond angle for trigonal planar is 120 degrees. A typical example of a trigonal planar molecule is BF3. Okay, boron as the central atom with 3 of the fluorines attached to it. And to complete the Lewis structure, we have the electrons attached. So we're not working on Lewis structures, but this is a typical example of the structure that will have a trigonal planar as its geometry and that will have sp2 hybridization. The next hybridization is the sp3 hybridization. The orbitals means to be one s orbital plus 3 p orbitals, and that will give us the sp3 hybridization. Molecules with sp3 hybridization will have a geometry known as tetrahedral. Okay, tetrahedral. And the bond angle for tetrahedral is 109.5 degrees. A typical example is methane, CH4. So you have carbon as a central atom with 4 of the hydrogens attached to it. Okay, so whenever you see a compound that has 4 things attached on that central atoms, we call that tetrahedral. And the hybridization will be sp3. We also have sp3d. In this case, you have one s orbital mixing with 3 p orbitals and 1 d orbital. And that will end up giving us sp3 and then d. Molecules with sp3 orbitals will have a geometry or a shape that looks like trigonal bipyramidal. Trigonal bipyramid or pyramidal. And the bond angle for such geometry is 90 degrees and 120 degrees. So they have like 2 different bond angles. A typical example is PCl5. Okay, so you have phosphorus as a central atom, and then you have 5 chlorines attached. Okay, so that's a typical structure you would get for that. Of course, as a Lewis structure, you have to put the lone pairs remaining, and this is how it will look if you're drawing out a Lewis structure. Okay, so that is a typical example of sp3d. It has 5 atoms attached to the central atom. And the last one I have is the sp3d2. Here you have one S mixed with 3 P's and 2 D's. That gives us X, 1X, P3, and D2. The geometry of compounds with sp3d2 is known as octahedra. And the bond angle for octahedra is 90 degrees. An example of a compound with sp3d is SF6. So you have the sulfur as the central atom with 6 fluorines attached to it. Okay. So of course, again, if you're drawing a Lewis structure, there has to be the lone pairs. And that would be the Lewis structure of SF6. So these are the different hybridizations we have. Thank you for watching and do have a wonderful day.